Hi folks, we're going to take a look at page 370, number 13. So let's take a look at the question here. So we have Mary leaving a dock and paddling her canoe at 3 meters per second. Okay, so we've got the water speed, and she heads downstream at an angle of 30 degrees to the current, which is flowing at 4 meters per second. Okay, so let's set up the diagram and then try to solve what they want. So we've got our stream. Okay, so she leaves 30 degrees from the current. Now the current, we assume, flows in the same direction as whatever the bank is here. So there we go. There's her speed at 30 degrees from the bank or from the current. Okay, and of course then there's the current, which is 4 meters per second. So there we go, going in the direction of the river. And so what do we have here? This has a magnitude of 3. This has a magnitude of 4, which means that our resultant velocity will look like this. Okay, so this is VR. Okay, so let's put the book aside and see how to solve what they're actually looking for. So the first question is, how far downstream does Mary travel in 10 seconds? Okay, so sorry about that. Let's get this all set up. So how far downstream in 10 seconds? Well, first of all, downstream means we're looking for a length that is in this direction here. Okay, and I think what I'll do is I'll end up drawing a separate diagram to show that a little more clearly. But first of all, let's determine what the resultant velocity is, and in particular, we can determine the magnitude is going to end up just being a cosine line problem, I believe. So the question is, I've got these two sides. How can I determine an angle here? Well, notice here that this current velocity, okay, that's going to be parallel to the shore, which I knew is this 30 degrees. So you have two parallel lines with a set third one cutting them. Okay, sorry about that. So we know that these two angles are going to be supplementary. So this is going to be 180 minus 30. So this is 150 degrees. And so now I can solve for this here. So this will just be the square root of 3 squared plus 4 squared minus 2 times 3 times 4 times cos of 150. Okay, so let's give that a quick calculation here. Okay, so square root, no, wrong one, square root of 3 squared plus 4 squared minus 2 times 3 times 4 times cos 150. You notice that I let the calculator do the work for me just to make sure I don't make some silly mistake here or there. And it looks like we have 6.77. Okay, so the magnitude is 6.77. Let me make sure I've got this as meters per second. Okay. And so if I wanted to calculate a direction, well, again, I always want to focus in on where the where the tail of the vector is. So I might as well calculate this angle here. Okay, so theta is just going to be equal to cos inverse of, okay, so its opposite side is 4. So we have 4 squared minus 3 squared minus 6.77 squared all over negative 2 times 3 times 6.77. Okay, so let's calculate that here. So we've got cos inverse, open up the numerator bracket, so 4 squared minus 3 squared minus 6.77 squared, and then divide by the denominator in brackets, negative 2 times 3 times 6.77, and we've got 17, we'll just say that's 17 degrees. Okay, so this here is 17 degrees. Okay, let's see if this will help us work the problem out. Okay, so in A is how far downstream does Mary travel in 10 seconds? Okay, so here we have leaving. Okay, so in 10 seconds, what we can figure out is we can figure out what distance, okay, she's traveled in the direction of motion in 10 seconds. Okay, so remember, we have v is equal to distance over time. So here we can write the distance as the velocity times the time. Okay, and here I've got a velocity because this is 6.77, okay, times a certain amount of time, which they tell us is 10 seconds. So this is 67.7 meters traveled in the direction of motion. But what I'm interested in is how far she's traveled downstream, which is just going to be this length here. So this just creates a right angle triangle. Now, this angle here was 17 degrees, but I know the whole thing here was 30. So 30 minus 17 is just 13 degrees. So there's my angle inside that triangle. Okay, and so now I just calculate this dd, I'll call that distance downstream. So here it looks like we're going to work with cosine. Okay, so we have cos of 13 degrees is equal to adjacent over hypotenuse. So the distance downstream will just be 6.77 times cos of 13. Okay, and here it looks like we've got about 6.6. Okay. Oh, wait a minute, I just noticed a little mistake. Here, this should be 67.7. I just noticed I looked at that one there, forgot that I had multiplied by 10. So this is actually 67.7. Okay, that number did seem a little small. Okay, so always a good idea to think about whether your answer makes sense or not. So here, let's try that again. We've got 67.7 times cos of 13, which of course should just be 10 times what we had. So here, about 66 meters. Okay. Okay, and there we have it. There's the answer to A. That's how far she travels downstream. So let's take a look at the part B. It says, what is the length of time required to cross the river if its width is 150 kilometers? Okay, so here now, again, let's kind of redraw the picture. Okay, so she's going to have to cross the whole river here. So let's draw it a little smaller. Okay, so starts here, goes in this direction, and eventually is going to cross the river. And remember that our angle here was 13 degrees. Okay, so essentially what we have to do is determine, okay, this is 150 degrees, 150 meters. Okay, so if we can just determine how far she has to travel, okay, and we know the speed at which she's traveling because we calculated that to be 6.77, we can then use our formula here. So I'm going to take again v equals d over t, but rearrange it so that I'm solving for time. So I need distance divided by speed. Okay, so we already have the speed is 6.77. Let's figure out the distance across. But here again, I've got a nice right angle triangle. So instead of working with the 13, I'll work with that 7. I'll work with, what is this going to be? Okay, you know what? Let's parallel lines here. Let's use the 13 degrees there so we don't even have to calculate anything else. Okay, so what I'm looking for is I'm looking for the hypotenuse. Okay, we'll call this total distance of this triangle. Okay, so opposite and hypotenuse, so sine of 13 degrees is equal to 150 over the hypotenuse, which is that thing we're looking for. So we'll just solve for that total distance, 150 over sine 13. Okay, and let's do that here. 150 divided by sine 13 gives us 667 meters. Okay, 667. Okay, and now I have enough information to calculate the time. Okay, so the time is the distance divided by the speed. So 667 divided by 6.77, which is my speed. And let's calculate that there. So 667 divided by 6.77, and that's equal to about 99. Oops, sorry, there we go, about 99 seconds. Okay, and there we have it. Okay, there's the answer to B. Okay, so just to recap, the first thing we did was we determined magnitude and velocity, okay, of our resultant. Okay, then from there we realized that in A we were just solving a distance problem. Okay, and what we really needed was the angle, and we used the velocity to find this distance here. And then in part B we were looking for time, so we needed to find the total distance traveled divided by its speed, which we had found earlier at the start of this problem. Okay, that's it for this one.